In this demo, we want to write a program to output the first n terms of the Fibonacci series. The first two terms are equal to 1, and f sub n can be computed by adding f sub n minus 2 to f sub n minus 1. We can start by declaring m and get it as an input, and then we declare the first two terms f1 and f2 and initialize them. And since we know the number of iterations, we are going to use for structure to output the results. So one option is to print the first two elements outside the loop. So we already know the first two terms and we can print them outside the loop. This way we can start from the third term and continue as long as it is smaller than or equal to n. And we need to compute the next element inside each iteration. So we need to keep it somewhere. We can declare this variable temp outside the loop, and then temp is equal to f1 plus f2. Now we need to update the value of f1 and f2. So f1 will be assigned by f2, and f2 will be updated by temp. And finally, we can print the term. So here we have the first 7 terms of the sequence, but we don't want this comma at the last iteration. So we can just remove it from here and check if we are not at the last iteration, then print the comma. We can also move this statement inside the loop. In order to do that, we can just start from 1 and check if I is equal to 1, then print f1 and continue. Similarly, if I is equal to 2, we want to see out f2 with a comma and continue. So we can try with 9 this time. So we have the first 9 terms. So the next problem is to check if a given number is a Fibonacci number or not. So the first approach would be to start from the beginning and generate all the Fibonacci numbers as long as they are smaller than the given number. And since we don't know the number of iterations, we should use while structure. So I'm just gonna keep this part of the code that we are updating the values, and we are gonna use while structure. So in each iteration we need to update the values, and we can just check if f2 is equal to n or not. So if f2 is equal to n, it means that n is a Fibonacci number. So we just need to print the it's a Fibonacci number and then break the loop. So I put if statement before updating f1 and f2 because we need to also check this condition for the first 2 terms of the sequence. And since the first two elements are 1, if the input is 1, it's enough to check it against F2. So here we just continue as long as F2 is smaller or equal to N. We need the equal part because we check the equality in the beginning of each iteration. And we haven't checked the last terms yet. So we need to include equal as well. So let's try this. So let's try with 5. It's a Fibonacci number. Try with 13. It's a Fibonacci number. And what about 9? It's not. So if you want to print that it's not a Fibonacci number, we can just declare a Boolean variable is Fibonacci, which is false. And here, instead of printing out, we can just set this value to true. And finally here, we can check if this Fibonacci is true. We print this. Otherwise, we print that it's not a Fibonacci number. So let's try with 9 again. So it's not a Fibonacci number. There's also another way to check if a number is a Fibonacci number or not. So here is this property that if a number is a Fibonacci number, either this expression or this one is a perfect square. So we're gonna try this way as well. So we don't need to compute the sequence anymore. We read the value and we just check if either of these expressions is a perfect square or not. So I'm gonna copy these two terms here. So if we call the first one A, we can compute it by having n to the power of 2 plus 4. Similarly, we can have B n to the power of 2 minus 4. Now I need to check if any of these values is a perfect square or not. One way to check if a number is a perfect square or not is to get the square root of the number and check if a square root to the power of 2 is equal to the given number or not. So we're going to declare a square root of A and we initialize it. Similarly, we're gonna have a square root of B, and then we're just going to check if either of them is a perfect square or not. So we check if a square root of A to the power of 2 is equal to A, or a square root of B to the power of 2 is equal to B. So let's just include CMAS and run the program. Let's try with 5. It's a Fibonacci number. And now let's try with 13. It's a Fibonacci number. And also let's try with 9, which is not a Fibonacci number. So it was one other implementation using the property of Fibonacci numbers.